Hey guys, welcome back to Nutrition Science. For today's topics, we're going to talk about metabolism and BMR. And I'm sure that you heard of metabolism before, but maybe you did, maybe you didn't hear about BMR yet, and that's what we're going to talk about. For today's assignments, number one, your assignment asking you to take notes. I know some of you may have left your notebook in school. You can do notes on a sheet of paper. You can do notes digitally, like type them out, whatever. Um, and then submit it. Or if you handwrite them, you can scan it and then submit that. And then also asking you to reflect on today's topic. So, like, did you learn something new? If you did, what was it? Maybe you didn't. Maybe it just reinforced some previous knowledge. That's fine too. Which topics were reinforced? And kind of have some fun with it. This is something that affects us all the time. And number two, I kind of talked about already. I just said your work can be handwritten, scanned, and submitted, or digital and submitted in that format. So, like I said, we're talking about BMR and metabolism today. So, let's get moving with that. So, first question is, what is metabolism? And this is kind of one of those topics that we're always talking about where I'm saying, oh, we have to talk about the urban myths. So, I think for most of you guys, if I asked you what is metabolism, you're just going to talk about how fast you digest your food. And if you eat and eat and eat and eat and you never gain any weight, then you have a fast metabolism. And if you just look at food and gain weight, you have a slow metabolism. And that's definitely part of it, but that's not the whole picture. So let's talk about that a little bit. Metabolism is actually the sum of all the chemical processes that occur in an organism. So every single thing, and digestion and absorption and excretion, those are just some of the things. Breathing in and out, that's part of your metabolism, right? Taking in air and then getting rid of carbon dioxide, and the rate at which you do that, that's part of your metabolism. How quickly you heal. Actually, people that have that fast metabolism, those are the people, like, your hair grows faster than other people. Your nails grow faster than other people. So there's a lot more to this than just how quickly you digest your food. So metabolism is a constant process. In other words, it's always happening. It's moving, it's grooving, it's going right now. Your metabolism is at work. Maybe you're breaking food down, and maybe there's just some other processes that are going on in your body as you sit here being entertained by this presentation. So this is kind of what we said. This includes not only how quickly you digest your food, but a whole collection of processes in your body, such as building muscle, breaking down nutrients into usable form, right? So everything that goes on in the body and the rate at which that happens, that's what your metabolism is. The sum of all of those chemical processes. So there's two types of metabolism that we're going to talk about. And that first one is something called catabolism, and that is the metabolic breakdown of complex molecules into simpler ones, often resulting in the release of energy. So it's just taking something big and breaking it down into something small. And an example of that, something that we've talked about before, right? Like glucose being used for energy. We're going to come back to that. Burning fat, breaking down tissue, like in the aging process when tissue starts to break down. But for our example, we've talked about this guy before, glycogen, and we've talked about how that's stored in the muscles, and in a time of need, the body can break down that glycogen, right, into glucose and energy, right? So this is something that you talked about in biology, and then we've talked about in class here. So catabolism, you're getting this larger molecule. Remember, it's a whole bunch of these stored in the muscles and liver, broken down. And when this larger molecule is broken down into a simpler molecule, and that's catabolism. So if we have the breaking down, we must also have building up, right? And that is anabolism. So anabolism, and I always remember, right, building up, the time and place where I grew up, anabolic steroids, right? You're taking steroids to build this massive amount of muscle. So anabolism, the phase of metabolism in which simple substances are synthesized, right, made or built up into more complex materials of living tissue. So an example of that could be the formation of protein from amino acids. Remember we talked about that? Polypeptides being built. It could be storing energy, or it could be building muscle or other body tissues. So we can take that same reaction that we just looked at, where we have glucose and energy, to simpler forms, and they build up, into something called glycogen, right? And we've talked about this before. And we just talked about it in the other direction. When we went from the larger molecule to smaller, that was catabolism. And we're going from smaller to larger. That time it's anabolism. All right? And we're going. So, how does this whole process work? And this is stuff, as we start putting it together, hopefully everybody's going to start remembering, oh yeah, we talked about that. We did a lab with that activity. So let's take a look at that. So after food is eaten, enzymes break down the proteins into amino acids, fats or lipids, into fatty acids, and carbohydrates into simple sugars. So this is something that we know that happens. This is something that's been a theme kind of all year long. We talked about this in the last unit with digestion. We're taking those polymers and they are broken down into monomers, because the monomers are the usable form of the nutrient that the body requires. So monosaccharides are the body's first choice for energy, but amino acids and fatty acids can be used as energy sources as well. We've talked about this, right? And we remember the order, right? Body's first choice, we said, are carbohydrates. Second choice would be, did you answer out loud? Second choice would be fatty acids, right? Fats, lipids. And then the body's last choice would be protein. And that would be not a very good situation if the body got all the way down to having to use protein as an energy source. Last choice. All right, so these monomers, right, those simple sugars, those amino acids, those fatty acids and glycerol, those monomers are absorbed into the blood. And that blood is going to, via circulatory system, transport those raw materials, those monomers, throughout the body so they can get to cells everywhere in the body, and the cells can use them for whatever they may need. All right, so now we had the circulatory system delivering these nutrients. So the cell now has received them, right? After they enter the cell, other enzymes act to speed up or regulate the chemical reactions involved with metabolizing these compounds. So again, we said there's thousands of enzymes in the body, and each one has only one job. Now, that enzyme is reusable, like we said, or your body would just be spending all its time making enzymes, but it only can perform one job. So now other enzymes help the body to use these monomers, again, for whatever the function may be. So the energy from these compounds can be released for use by the body and stored in body tissue, especially the liver, muscles, and body fat. And again, this is a topic we've talked about. We now have energy that can be released, it can be used, or some of it can be stored. Not a lot stored, right? And when we're talking about we're storing energy, we talked about using some glucose. We've talked about storing leftover glucose as glycogen. Then anything that's left after that, some of that may end up being stored as fat. That's what the body does. When it has excess of something, it doesn't know what to do with it. It stores as fat, because that can be used as an energy source in a time of crisis. And then whatever's left after that is going to just pass through the body. It will be excreted as waste. So that brings us to BMR. right? So what is BMR? And we know it's going to have something to do with metabolism. You may or may not have heard of this one before, but let's talk about it together. So BMR is basal metabolic rate, right? But what does that mean? So BMR is a measure of the rate at which a person's body burns energy in the form of calories, capital C, remember, while at rest. So this is if you were to just lay in bed all day, how many calories you would need to consume to maintain your body weight, right? And that's for your body to maintain all its functions properly. That is your basal metabolic rate. So this is just a starting point. When people talk about how many calories should you be eating, this is different for everyone. And we're going to set this up with a formula in a minute, but keep in mind, everybody is different. People are different sizes, different weights. So how much you should eat is going to be different for everyone. So when we're looking at a food label and a food label saying, oh, based on a 2,000 calorie diet, that's cute. But I always say when you look around the classroom, look at the biggest person and the smallest person, and there's no way on earth they should be eating the same amount of food, right? Even for just the BMR. We're not even talking about beyond that yet, but we're going to get beyond that. All right, so BMR can play a role in weight gain as well, and actually as well as weight loss, right? Maybe I should have just said in weight management, but it will play a role. All right, so what is BMR? So I'm giving you this example. I'm saying a person with a low BMR who burns fewer calories while at rest, which means they have a slow metabolism, low BMR, will gain more pounds of body fat over time as compared to a similarly sized person with an average BMR who eats the same amount of food and gets the same amount of exercise. So some of this is genetic, right? That's what that means. Some of it is genetic, and some people just naturally have a faster or slower metabolism. And this one can get chalked up into the life's not fair thing. I know for me, I've always been at the other end of this argument where it's always been hard for me to maintain body weight, meaning, I'm always trying to not lose weight. And while I do train a lot of cardio, I do also lift and do muscle building workouts. If I don't do those, then I lose all my weight. So I've been at that end of it where other people are like, oh, I wish I had your problem, and I always think I wish I had your problem, that I could maintain my body weight based on how I'm eating and training. So the grass is always greener, but this is just definitely a thing. We're going to talk about this in a second, but there are other things that could impact your BMR. But just keep in mind that this is just, where you are naturally. All right, so what influences BMR? So maybe in your head, I want you to start thinking of some things. So when we go through it, you could be like, oh, yeah, I had that one. What is going to affect your basal metabolic rate? How many calories you burn while at rest? And we're going to have a nice little list here. So we talked about this on the last slide, and that's genetics. Some people are, whatever, lucky, unlucky, right? Again, this goes under the life's not fair category. Some people naturally have a fast or slow metabolism. I had friends in high school that never worked out a day in their life, and they had all this muscle, and they were shredded, and life just wasn't fair. And some people put muscle mass on easier than other people. We're going to come back to that topic later in this unit, but this is just genetic. Some people, they eat whatever they want and they never gain an ounce. And I know you guys are all going to be like, oh yeah, that's me. But I'm not talking about when you're 15 or 16 or 17 or 18. There's people that will carry that. For me, I always ate a lot. My diet at your age was terrible. But, it's, I think, a pretty decent diet now. And when I was a kid, everybody said, "Ah, wait till you get into high school. It's going to catch up to you." And when I was in high school, people said, "Wait till you get in your 20s. It's all going to catch up to you." And they told me, "Wait until you're older." And you know what? I'm not going to listen to that anymore. Now, some of that is lifestyle, but a part of that is genetics as well. So let's move on from here. So we have health problems. So my question to you guys is, think about it. Which organ is going to have control over metabolic rate? And I've actually had a test on this before. It's like a 3-hour blood test, and that is checking my thyroid. So the thyroid is in charge of metabolic rate. If you have hyperthyroidism, right? It's hyper, it's fast, then you're one of those people with a fast metabolism. You can take medication to slow that down. That would help you to put weight on and regulate some other functions. You can have hypothyroidism, where you have a slow metabolism, and then medication can be taken to speed up your metabolism to help, use everything a little bit more efficiently. So that would be one example of a health problem. So activity levels, like exercise. Take a wild guess. The more you exercise, what does that do? Increase or decrease your metabolic rate? And we all say increase, right? So the more you exercise, the more calories you burn. But we're not talking about your exercise metabolic rate. Remember, we're talking about BMR, the basal metabolic rate. And that basal metabolic rate actually stays elevated. If you're somebody that exercises, then you burn more calories at rest than other people. When we go back to that sample question I had before, 2 people eat the same, do everything the same body weight and all that kind of stuff, but one of them worked out in the morning and the other one didn't. Sitting in class throughout the day, that person that exercised, their basal metabolic rate stays elevated for some time throughout the day, and they're burning calories at a higher rate just sitting there because of exercise. So like I said, not just while you're exercising, but there's an impact to the body for some time after you exercise. So let's move on. We have body composition. So for body composition, lean muscle has a faster metabolic rate. And what I mean by that is the more muscle you have, the faster your metabolism. The muscles need to eat. You need to feed those muscles. Some great videos to watch, listen to people that are professional bodybuilders, guys that weigh in there, 200 plus pounds, and they're over there talking about, how they're eating 10,000 calories a day because they need to be able to maintain that muscle mass, that body weight. So if you have more lean muscle, you're going to have a faster metabolism. Back when I was younger, I tell you guys stories all the time how I had friends that did bodybuilding, and they used to tell me how they hated having to do cardio because they try to do cardio with the idea that they're going to burn fat. And they hated it. But now, the last several years, the thought has been, you don't need to do cardio. Just lift more, put on more lean muscle, and that's going to increase your metabolic rate, therefore burning the unwanted calories like from lipids and things like that. So you don't even need to do the other stuff. But that's body composition. All right, gender. So men usually, right, have more lean muscle than women. And that's not to say that there aren't some women that have more lean muscle than men, because we know that there are. But in general, men usually have more lean muscle than women. Therefore, men usually have a faster metabolism than women, right? So that's why usually, men eat more than women. And again, maybe with some of you guys, you're saying like, oh yeah, my friend, eats so much. And again, you guys are young, so you're kind of an exception to a lot of these rules. So gender, usually men have a faster metabolism than women. And that kind of ties in with body composition. All right, moving on. So we also have age. right? And a few things. I'm going to talk about tying a few things in together. So with age, like I was giving you that example before, wait until you're in high school, wait until you're in your 20s, wait until you're in your 30s. So metabolism, usually it slows down with age. So when you're younger and you're like, I could eat the whole McDonald's menu and not gain an ounce, and then you get older and suddenly you say McDonald's and you're gaining weight. So with age, your metabolism will slow down. Now, I think there's a lot of other factors that kind of tie in with that, and you'll see this drop here with age. Even for you guys going from high school to college, and we keep talking and joking about the freshman 15, but if you take a look at how many of you guys, and let's not even talk about age at this point, how active are you? Like how many of the graduating seniors play a sport, right? And then how many of you guys are going to continue to play a sport or work out in the gym or at the pool or running or whatever on a regular basis? And I think, we see a drop in activity level when people get to college, and that's going to be a reason, that kind of plays hand in hand with age. And as these levels drop, body composition is going to change, and you may lose some of this lean muscle, therefore slowing down your metabolism. I happen to think it's not just an age thing. I think that there's other things that play in with age, but that's my opinion. So that's good. So that's age. So let's keep moving. So body temperature and body size. So this is a weird one. One of the things, right, we've talked about homeostasis or equilibrium. Maintaining body temperature is part of your metabolic rate. So when we talk about body temperature, someone that is leaner, that's thinner, it's going to be harder for them to maintain body temperature. And I'm talking about your body temperature, right? On the thermometer, we won't say Celsius, we'll just say regular Fahrenheit. Like most people know, like, 98.6 is normal body temperature. But there's not really like a normal. That's most people. Some people, their body temperature may be slightly higher and lower. That's okay. What we're talking about is the ability to maintain body temperature. So if you have less fat on your body, it's harder. You probably get cold easier when you're outside. You probably get cold easier like in a swimming pool. And therefore, your body's working harder. You have to have a faster metabolic rate to be able to heat your body up to stay warm. And then contrary to that, if you have a lot of body fat, then it's easier, right? That acts as insulation. It's easier for you to maintain body temperature, therefore having a slower BMR because you don't need to work as hard to stay warm. So this is kind of one of those like what came first, the chicken or the egg things, because I'm have a fast metabolism, that's why I'm skinny, or I'm skinny because I have a fast metabolism. So I don't know. It's a mystery for the ages. So let's move on from here. All right, so the last one on here we have is something called energy supply. And I put a note in here and it says during time of famine, right, like a starvation diet, the body automatically lowers its metabolic rate. So, this is something that's argued. Some experts will say that if you did a starvation diet, you're trying to impress somebody. Maybe there's a wedding coming. Maybe it's a vacation. Maybe it's the prom. I don't know. For whatever reason, we probably have seen or heard or know people that have done like, I'm not eating anything until this event. And they starve themselves. So yeah, it's going to be effective in losing some body weight, but you're damaging your body. So when you do that, like I say, some of the experts are saying doing that for a few weeks can slow down your metabolism. It can take 6 months to a year for your metabolic rate to recover. So this is something that, if you've ever had a pet snake, snakes can do this, right? Snakes can eat And after they eat, some of them don't need to eat again for a week or a month. I've heard stories. I had a 6 foot python, and a day or two after I fed it, it broke out of my tank, and it was missing in my house for at least a month, and couldn't find it. I didn't know what was happening with it, and one day I found him, and he was fine. Put him back in the tank. He was all good to go, because what snakes can do is they lower their metabolism, their BMR, right? So then they don't need that same amount of calories to survive. So our body does that same thing. So now you've starved yourself, you got to the weight you want, you went to your event, and you start eating again. You have trained your body to store calories because it doesn't know when it's getting food again. So people that do these starvation diets, they usually gain all the weight back that they lost and then some. So they end up usually heavier than where they started because of the damage they've done to their body. Now, that's not to say that you can't get that back. You can, but the body has to recover from that abuse. So let's move on from there. All right, so how do you figure out what your BMR is? So we have two formulas here, and I'm going to ask you to calculate your BMR, right? I'm going to flip over here. So use the formula I said from the previous slide, but I put it here. Determine your BMR. Do this for yourself right now. What is your BMR? If you're a woman, follow that formula. If you're a man, follow the other formula. Take that, right? Let's convert that. I'm going to just talk while you're figuring that out. And this is going to be your BMR, your basal metabolic rate. How many calories do you burn while your body's at rest? If you want to maintain or gain body weight, this is the number you need to reach. And then we're going to talk about, hopefully you're not just sitting around or laying in bed all day. So this number again is going to be the number that tells you how many calories you need at rest. When you take a look, right, your BMR, you have a constant, girls. Then you have 4.35 times your weight in pounds, plus 4.7 times your height in inches. Reminder, how many inches to a foot? And I hope you said 12. Minus 4.7 times your age in years. So now these constants, however they did arrive at these, 655 for women and 66 for men. You have your weight, because we talked about weight being a factor, and you have weight and height, so to kind of try and figure out your body type, and then your age, because again, it's going to have a bigger impact, this number, if you're older, because your metabolic rate is slowing down with years put on you. So figure that number out, and again, that number is going to be how many calories you need to eat while your body's at rest. And again, if you're bigger, right, whether that's because you put all this muscle on in the time we've been out, that number's going to be higher. If you're a smaller person, right, smaller frame, all that, then your number is going to be a little bit lower. But this is just BMR. This is, again, your body at rest. So let's kind of take this a step further now that you have that number. All right? So I said, now that you have your BMR, use the chart on the next slide to determine which group best describes your lifestyle and calculate total calories burned. So what I'm talking about here is how active are you? So if you take a look here, somebody that's lightly active, that means you do light exercise or a sport 1 to 3 times a week. If you're that person, you're going to take your BMR that you just calculated and multiply that by 1.375. And that's how many total calories you should be eating. Now again, some days you may be more or less active than others, and this is like not taking that into account, so keep that in mind. And it's telling you that's total, how much you should be eating to maintain your weight. You want to lose weight, you'd eat below that. You want to gain weight, you would eat above that number. We have moderately active, so then you're doing sports 3 to 5 times a week and you have a constant. We have very active, and that's someone that exercises hard 6 to 7 times a week, and you have a constant for that. And then there's extremely active, like hard daily workouts, sports, maybe a very physical job. Maybe you're doing doubles, you're training twice a day, then you're going to have the highest number. So again, the more active you are, the higher the number, the less active, the lower the number. And this is telling you total calories, right? Oh, I missed that. A sedentary person, but that shouldn't be any of you guys. Light or no exercise, you have a desk job, and there's a number. So figure out your numbers. Who are you? What should you be eating? And we'll come back to this topic. I just want to give you a reminder. Hopefully you took some notes, or you're going to type them up after. Go back and look at the slideshow. Please do that, and then let me know what's something that you learned, something new. Maybe you knew everything, but it just reinforced. So what would those topics be? And submit them into Classroom. And that's it, guys. I will see you all next time.